Today on Ask This Old House.
And in most houses like this, 20 to 30% of the air in the ductwork never makes it to the living space because of small leaks like this. So today I'm going to seal the ducts from the inside.
That's next on Ask This Old House.
Well, Mark, your house is just beautiful.
Thank you, Richie. We love it here.
So what's up?
Well, we wrote to you guys about our heating and cooling system. It's a forced air system.
All right, I can see a supply register right here, and that's going to blow warm air in the winter right against the glass right there. That's good. You should have a return here somewhere.
We have a return right around the corner.
All right, so the air goes back to the furnace to be reheated right there. So what's up?
Well, we put a new furnace in about 11 months ago. We're hoping for a greater return on our investment. Our utility bills are much higher than we thought they'd be.
That's not good.
No, it's not good. And you know, the other big problem here is that we'd like to see more consistent temperatures in the house.
Inside the house?
Specifically upstairs.
Okay, well, you're not alone. A lot of people with a forced warm air system complain about being uncomfortable.
Yeah, it really has been. And you know, another thing we noticed is that it's just very dusty. There's just dust everywhere. It's very annoying.
Let's see what you got.
So here it is.
You have a furnace. Looks to be gas-fired. Yep, okay. So inside this box, you've got a blower down here that pushes the air up across a heat exchanger. That'll heat the air in the winter. Above it, you've got an air conditioning coil right here, and that'll cool the air in the summer. Now that fan pushes the air up into this trunk. Now this trunk right here, I can tell you, is the supply trunk because it's insulated. Okay. And you can see right here, there's branches that go upstairs right there. Looks like you got some other branches. Yep, branches that go all the way along right here. Now, this ductwork is insulated, but it's not sealed. People see this insulation and say, oh, my ducts are sealed perfectly. Well, I've seen it so bad that when you turn on the furnace, all of a sudden, the insulation blows up like that, which means the air's coming right out.
Right.
And it's a big deal in this country. You can lose as much as 20 to 30% of duct losses where it doesn't actually get up to the place you want to be.
Wow.
You're losing it to the attic, you're losing it to outside, you're losing it to the basement. Okay, so this is the supply trunk right here, insulated. But over here, you can actually see really the issue with ductwork. Here's the return coming from upstairs, here's the return right here. And when these come together, you can see that the installer has sealed this with a mastic, sort of a rubberized cement to seal up the joints. The mastic is applied with a brush at any place that air could ever leak out. It's messy, but it's really effective. You also could use a foil tape to seal any of the joints that are easily accessible. Look at the challenge. You've got a metal trunk, and the only thing holding it together is this metal cleat, and that's not airtight. So your system is not unusual. You've got all this ductwork exposed down here, and what we could try to do would be to seal the ductwork from the outside. Well, it's pretty straightforward on the return side right here, right? We can get at it.
Right.
It's not as straightforward on the supply because you have to pull down that insulation, seal the ducts, and then re-insulate. And even if we did all that perfectly, you've still got some great percentage of your ductwork that's actually up inside your building that we can't get at.
Right.
So it could leak to the attic and everywhere else. So what I actually want to do is do something new. I want to show a technology where we can seal every bit of this ductwork perfectly from the inside.
Sounds great.
All right. Mark, say hello to Steve Taylor. He's going to help us seal the ducts today.
Hey, Steve. How are
Hi,
you?
Mark.
So how'd you get started?
So we've already started upstairs. We've sealed all of the supply and all of the return registers. So now any leakage that we measure is coming just from the ductwork.
Okay, great. And then you tested the ducts?
We did. We ran a pre-test.
Okay.
So we used the fan in this box
Okay.
to blow air into the duct system and see how much air is going to leak out through the...
So that pressurized the ducts, and you got it tied into the computer here.
Correct.
All right, so how did we do? We lost 307 CFM, cubic feet per minute, and that's equivalent to a hole in your ductwork of about 58 square inches. That's a big hole.
Wow.
So let's do the math. 307 CFM, this is a 4-ton system. That's like just under 20%, right?
Correct.
Okay. So 20% is not coming back to be reheated. You're heating your neighbor's house.
It's unbelievable.
All right, so how do you seal the ducts?
Well, first we're going to start with the sealant.
So that's a liquid. Is that what this is here?
It is.
Okay, sort of milky, sort of rubbery. Okay. So great. How do you get it into the ductwork? It's a liquid.
So in order to seal the ducts, we need to do it as an aerosol. So we're going to use this sealant. We use the same fan that we used for the
Yep.
pre-test.
Yep.
We have a nozzle that injects the liquid into the duct. The small particles that are now in aerosol travels through this flexible duct here to a Y branch.
Gotcha.
Then it can go to the return and the supply, and we seal both at the same time.
So I understand why we would seal the supply, but why do we seal the return?
Well, think about it. You know, you got heated air coming out here. We want to keep that in the ductwork. Well, on the return side, it's under a negative pressure, so it's pulling air in. Remember you complained about dust?
Yeah.
Well, if these leak and there was any dust down here, it would be sucked into the ductwork and then distributed all into your house.
Okay. So all this happens from inside the ducts?
It does. We're not going to actually line all the ductwork. We're actually going to only seal where the breaches are, the breaks in the ductwork. So we might see a little bit leaking out from right here. In order to prove to you how it works, though, we're actually going to cut in a hole right here with a screen to really see it at work.
Great.
So with this hole and the window screen over it, I've actually simulated some of the duct leakage you have upstairs in the building. So we all set to go, Steve?
We are.
Let her rip.
So we'll activate the machine.
Okay.
The fan will turn on, and it'll start to inject the sealant.
Here it comes. Right now, the airborne sealant is flowing through the pressurized ductwork, and it's squeezing out just where they have an opening in the ductwork. As it flows through those little cracks, it catches on the crack and actually coagulates to seal any duct leakage. All right, so we've been running for about 10 minutes, and we've gone from 300 CFM of leakage down to 100 already, and we're not done yet. Pretty cool. Now, any of the sealant that happens to leak into the living space can be captured from this scrubber fan onto the filters.